Video lecture 4.1, Weather and Air Masses. And before I begin, let's differentiate between two oftenly confused terms, weather and climate. Weather is just simply the day-to-day changes. It's what's happening outside. Climate is the average of the weather, and so it's what we should expect to have on this day of the year given our location. So it's two different things. And so weather, what's happening outside, the daily changes, whereas climate is the average of our weather. Well, now we'll spend some time talking about air masses and defining and differentiating between them. Air masses are the main actors in weather, and so when we think about Hollywood, who has the greatest amount of power, who are the main actors of Hollywood, it's going to be your Brad Pitt, your Angelina Jolie's, your Tom Cruise, whoever he's married to. You're going to have Chevy Chase if he's still around. Those are the people who have the greatest. George Clooney, they're the people that have the greatest pull. And so when we think about weather, air masses are the biggest influencer. Weather is largely influenced by air masses, and so air masses are the main actors of weather. Just like you and I, we take characteristics of where we come from. So if you grow up in an inner city area compared to a suburban area, compared to a rural area, you're all going to be more than likely taking on the characteristics of where you originate, and so do air masses. One of the things we talked about in video lecture 3 is the fact that wind is obviously on Earth's surface, and that then puts these air masses in motion. So it takes an air mass that might form over a water body and then moves that air mass over to a land mass, a land body. One of the things is in physical geography, we classify different phenomenon based on different characteristics. In the case of air masses, two main characteristics: moisture and temperature. So when we think about moisture, strictly we have either our wet places or our dry places. And so our wetter places are maritime air masses versus our continental, more drier air masses. So we can go ahead and look at our definition of air masses, take on the characteristics of where they come from. So a air mass that forms, it's a maritime air mass, no doubt that it forms over a water body, where a continental air mass is going to form over a land mass. So kind of going back to our definitions there. Now our other characteristic or other classification would be temperature, which is largely due or largely attributed to latitude. There are different types. We've got a polar one, so this is going to obviously be a air mass that's found at a higher latitude, and then tropical, obviously going to be closer to the tropics. Equatorial, that's going to be right there along the equator, and then Arctic and Antarctic, which don't affect us too much here in Indiana. So one of the things is, if I say that there is an MP air mass, we know that that is an air mass that probably formed somewhere close to a high latitude, so in the 60 to 90s, and then also is one that formed over a water body. Whereas an MT air mass would be a wet but tropical air mass. And so we can differentiate different air masses based on their moisture and temperature characteristics. Air masses that most affect us here in the United States and North America, and especially here in Indiana, are the continental polar air mass and the maritime tropical air mass. The continental polar air mass is cold and dry, and it's definitely going to be one that's influenced by high pressures. Just those names imply. Cold and dry should just be a knee-jerk reaction that you know that that's in high pressure. So a high pressure does dominate Indiana through certain parts of the year, and that's obviously going to be from the north. One that doesn't influence us that much is a maritime polar air mass, an MP air mass, but we do have occasional influences here in Indiana, and so that's, as the name implies, is going to be a wet and cool air mass that is going to be a low pressure, and so we're going to see this being typically a low pressure that brings precipitation to the northeastern United States, which they get in New England, a steady dose of precipitation throughout the year, and then the northwest United States, which Seattle, of course, is known for their heavy precipitation that they get throughout the year. And so those MP air masses heavily influence and add the vegetation, the lushness that we find in Pacific Northwest. MT air mass, maritime tropic, it's going to be a wet, humid, but also warm air mass. And so differentiating it from an MP air mass is it's going to be warmer. So it's going to be found in tropical areas. Indiana, we're definitely influenced by an an empty Gulf Atlantic. So the empty air mass that forms over the Gulf of Mexico, but also one that forms over the Atlantic Ocean, just off the coast of the southeast United States. That definitely influences us in Indiana. The other one, empty Pacific, does influence us occasionally, but it's going to influence more of those California, more of those extreme West Coast climates. What's interesting about this one is it's a bit drier. We'll explain that in a future discussion. Finally, a CT air mass, a continental tropical air mass. This is going to be one that's going to form over Mexico, over New Mexico, over Texas, parts of Arizona, and it's more going to be around during the summertime. But its characteristic, as the name implies, is quite dry and hot. So here's a key for the map quiz, but these are the dominant air masses that exist on Earth. If we look at North America, we can see the empty air mass that's found there in the Gulf/Atlantic, there in the Caribbean. Also, that's continental tropical air mass that pops up more in the summertime. It's found there in the American Southwest. Of course, we've got an empty air mass that would be found over there by Hawaii, whereas an MP air mass is what we would find on both the New England coast, but also the Northwest, the Pacific Northwest, and most of the southern part of Alaskan coast. Of course, way up there in Alaska, they're influenced by more Arctic air masses, but also that continental polar air mass that we see there in the middle of Canada. Time for a pop quiz. And so what you're going to do is you're going to place various air masses onto this fictitious Earth here that looks like Mr. Burns. So the brown area representing land, and the blue area representing water. So what you're going to do is pause it right now, and then try to place each of those, and then after you unpause it, I'll then show you where you would expect to find each of these air masses. So pause now. And if you've now unpaused it, we have the equator shown here, and so that's that maritime equatorial region. Of course, you weren't asked to identify that one, but then there will be where we'll find our MT and our CT air mass. In each of those various locations, and then eventually our CP and MP air mass. And one thing you note is, well, wait a minute, there's not a CP air mass there in the southern hemisphere. Well, that's because there's really no land mass there close to the poles, which is something that we'll maybe see in reality in real life Mother Nature. And like I said, those air masses, one of the things is wind moves them to new areas. And so an MT air mass now can maybe be moved to a land mass via wind patterns. And we've already talked about this in video lecture 3. And so we're going to take those concepts and apply them to what we just did on our pop quiz. And so we've got above the surface, we've got these wind patterns, these predominant wind patterns that we've discussed in video lecture 3, that then move these air masses, which take on the characteristics of where they come from, and move them to new areas, which we conceptualize here with our previous examples. And so a CT air mass in the northern hemisphere that forms underneath the subtropical high pressure is now going to be moved to the north and to the east because of the underlying westerly wind patterns that then move it to a new area. And so we can see that conceptualized here as far as the idea of how an air mass can then move to new areas via those overlying predominant pressure belts and wind patterns. And just another reminder that to our north, we've got a high pressure, the polar high pressure. To the south, we've got the subtropical high pressure. And once again, high pressures diverge, separate. And so we're going to be getting winds from the southern subtropical high pressure that are going to the north. They're going to be those MT air masses and those CT air masses are going to be moved to the north because, once again, of that overlying dominant pattern, whereas those MP and those polar air masses are going to be moved to the south, once again, because of the corresponding high pressures. So this is the general pattern, the general direction each of these air masses move in North America. And once again, a friendly reminder as far as the winter pattern and how it differs than the summer pattern, which we'll see right now, as everything moves now to the north. And so the subsolar point moves the subtropical high pressure more in a northerly direction in terms of the northern hemisphere. Here would be the winter pattern that we would expect to find. That MP air mass over the Pacific Northwest plays a very, very good critical role in the winter time in that area of the country. Of course, we put in our polar high pressure and our subtropical high pressure. Here would be the winter pattern. So the polar high pressure is a little bit further south than where we'll see it for the summertime. But in the wintertime, we are heavily influenced by that CP air mass. That continental polar air mass dips down deep within the Great Plains in the Midwest. And so we're heavily influenced in the wintertime by that continental polar air mass. However, in the summertime, we see a different pattern. So subtropical high pressure moves to the north. Once again, that's related to the subsolar point and its movement to the north as well. So that continental polar air mass also moves further to the north. And so in Indiana, in the summertime, we're definitely much more influenced by a maritime tropical air mass, which explains why we have quite high humidity. It's quite muggy oftentimes during the summertime in Indiana. But once again, that continental tropical air mass over Arizona and the extreme American Southwest does appear and is has more of a role in the summertime, whereas those maritime polar air masses don't have as much influence on both the northeast and northwest coast of the United States.